Hello again, it's Cliff here from Down Under. In this video I'm going to go through using subroutines to move to the different work offsets. So you can see here I'm making up a work holding fixture that holds these parts, and I want to do the same engraving machining operation in all 8 parts. I'm now going to make up some clamps to hold the parts in place so that I can let it run automatically while I go away and do something else. So instead of just copying and pasting the code 8 times and then putting a G54, G55, G56 at the beginning of each one and so on, so this is a bit rough and ready. I'm going to use a more elegant process using subroutines, so I just have one bit of code and a little bit of subroutine instructions so that it goes back through and loops the code 8 times to machine the different parts. So I'll go through how you might do that now. I've spent a bit of time doing research, looking at different YouTube videos, going through the forums, and yeah, it takes a lot of time trying to work out something that works for PathPilot. A lot of the information is for Haas or for Mach 3, or it's for PathPilot, but it's a long-winded way of doing it. So I've tried to sort of pare it all down to the bare minimum and a nice easy way to do it for PathPilot users. And if I need to remember how to do this in a couple of years' time, I just need to watch this video again. Alright, cheers guys. There's different ways of producing the Gcode with the multiple offsets. You can probably go back to your CAM software in Fusion 360, or here I'm in Bobcat CAM, and there's probably ways of, but depending on how your post-processor is set up, you can probably generate the code that's got the different work offsets so that you can go straight in and just use that code directly. But there's a couple of disadvantages with that. One of the disadvantages is that if you've already got the code for producing one part, for example, you might have fine-tuned it over time, over several runs, and made little adjustments to it, so that if you go back to your CAD file, you won't have all those little tweaks in it. And also wanted to use PathPilot's conversational sequential serial number and join that in with it. So I had a piece of working code that produced the engraving with the sequential serial numbers already. So it was easier if I could find a way just to edit that code on the machine. And so that's why I've gone ahead and done it that way. And I'm sure some of you will be in that situation too, where you don't want to go back to your CAM software, even if you could, because you've got an edited code already and you don't want to go back to its earlier form. I started doing a bit of research into subroutines and looking at YouTube videos and websites and forums, and probably all in the wrong order. Had a look at a Haas video, how production shops use M97, you know, scribbling down notes as fast as I was watching the video. M98, P10, P11. It didn't really look like the language PathPilot used. I thought, well, this isn't really very helpful. I need to move on. This Mach 3 subroutine YouTube video, and again they use different codes M98P1, M98 G56 and so on. And then I had a look online in the forums and found this one. But again, this is PathPilot, and it's using different examples of Gcode to call the subroutine. And then I had a look at my earlier video that I did on subroutines several years ago. It seemed much simpler, and so I just used that and gave it a try. In case you're having trouble finding information about PathPilot subroutines, if you're like me, you just use Google and YouTube and you crash around and sort of stumble onto various information and finally find the best source of information. In this case is in the Tormac website or their operator manual. So just to help you navigate that in case you're having trouble, go to your Tormac website, go to training, machine code reference, then down here on the right hand side we have advanced programming, and then at the bottom we've got subroutines, subroutines reference, conditional subroutines reference, repeating subroutines reference, and looping subroutines reference. And here I've got it up here. So here's an introduction to the subroutines here, which is subroutines reference. Then we've got a page on conditional subroutines reference, if and if, repeating subroutines reference, looping subroutines reference, do while loop example. Now I wish I'd seen this at the beginning, it would have saved me a bit of time. So anyway, I'll put that in the video also. So anyway, once I got to this Tormac information page and read the subroutines reference, there seems to be three main types: the conditional type, if, else, if, and if example, and repeating subroutines, or you've just put in the number of times of the repeat, and looping subroutines, while, end, while example, and here at the top, do while loop example. I find this type of academic stuff really difficult to follow. I'm more of a practical engineer than a theoretical engineer. It doesn't seem to be the conditional one for doing the different work offsets, or the repeating one. So it must be one of these two, do while loop example. But I find this stuff really difficult to follow. And after sort of struggling to digest it, I thought I'll just go and have a go. I'll just put it together how it seems logical and try it, see if it works. Alright, so here we are. I've just put together a short piece of sample code so that I can use as a template in the future. And I've stored it in my file. Let's go back to there. So down here there's a subroutines folder, and here I have a subroutine template, and this is the code. Now this is just a quick overview. Okay, so there's a graphic display of the code. It's just a simple little move to keep it short and sweet. So we've got one position there in G5.4, one position there in G5.5, and one position there in G5.6. So I'll just quickly run it now so you can see what I'm doing. Okay, over to the machine, I'll push cycle start and it'll go to the beginning. G5.4, drop down, make the pass, across to G5.5, drop down, make the pass, and across to G5.6. And now if we press cycle time again, it'll go back to the beginning. So there's a little template of code showing using subroutines using G5.4, G5.5 and G5.6. So I'll just break down what that code is and how you can produce it. Okay, so let's have a look at that bit of Gcode. So we'll go into File, Edit Gcode. So we've got it set out nicely here now. Right, so it's just a short, simple little piece of code in the middle produced by the conversational programming, and this is the code here that we're going to call the subroutine content, the actual bit of code, and that's the one that we're going to loop around the various work offsets. So to start with, at the top section, we've just got the starter blocks and the introductory code, you know, the sort of setting all the various general parameters, tool numbers, spindle on, and at a certain point you want your subroutine to start, and at that point, and it depends on the job you're doing, whether you want the spindle on and off each time and the coolant on and off each time, but in my case I want the subroutine to start down here after the spindle on. So the first bit of subroutine code you need to know is a O, not a 0, and the number of the code, we're going to call it O1. So O, the number, we're calling the code O1, and sub, S-U-B. Then we've got our actual code in this section here, and then we enter in again O1, end sub, just that simple little bit there. So now we've got the beginning and the end of the program that we want to run. Now the next stage is calling the work offsets. So we just put in here O, letter O, 1 call, G55, then O1 call, G56, then O1 call, and finally spindle off, G30, end of program. So you know that I can't explain exactly the theory behind all of this. It doesn't quite seem right to me. This doesn't seem to be as much code as some of the examples. You know, I've read several forums and looked at different videos, and there's much more complicated sets of subroutine code explained. This is way more simple. It seems to have bits missing, but it works, and there's no error messages, and so I can't see the problem with using it. So I'll just run it again now. ISO view, shut it down, so you'll be able to hear it in the background, and we can watch the tool here. Let's go through, we'll go through single block. Set single block, cycle start. Can you still see that okay? Okay, cycle start. So it's going through the introductory start block. Now we're going to get the spindle on, spindle's on. Now we're beginning the bit of code. So it's going to drop down, do that move, Z move, X move, up to 10 to G30. Now this is where the code we've put in comes in. We've got the O01 end sub. It's jumped through now to the O1 call and G55, and you can see down here, hopefully you can see down here, G55 is now installed as the work offset, and it'll now run back through it again. So it's going to run the code again there. And now it's jumped through to G56. G56 is installed there. And it'll go back through there and so on. And that seems really simple to me. It seems a bit too easy. I haven't got nearly as much content as some of the advice I'm getting online, but it works. So I thought I'd make a short video of that. Please put your comments in below, and perhaps some software engineer can explain what is missing and why it matters, but it's, at least in this example, it works fine. Okay, so you've got a fixture with a couple of T-nuts, a couple of cap screws. Doesn't take a second to dial it in. You could put some keys underneath, but they're never highly accurate. You could hold it in the vise, but then it's up high in the air. And the further it is away from the slides of the X and the Y, the less rigid it's held and the less accurate it is. It's a good idea to mount your work at different positions on the table, because otherwise, if you're always putting it in the middle, you're wearing out your ball screw in that position and the table in that position. It's better to have it to the left and the right and the front and the back to more evenly wear out those components. So I'm going to set the work offsets into the work offsets tables in PathPilot. I'm just going to use my probe. There's other ways you could do this because they're of a certain pitch and you could enter the values, but this is quick because it's an impact tolerant probe and I can just zoom around with the probing routine and quickly set those 8 different positions. So I could set them straight in the little recesses, but I'm going to use this sample part which I use for setting because it also sets the Z height. So I'll just go around and quickly set those. I'll do a couple with the camera on a tripod so you can see how quick it is. So on the PathPilot probing routines, I'll be using find center set work origin to get the X and Y, and then over here probe Z set work origin to get the Z. So that first part offset we're going to call G54, so we've entered that in the MDI G54. We've gone to the probing page and we're going to go find center set work origin. We can be quite relaxed because it's impact tolerant, and if I crash it, I've got a lot of retract before it would do any harm. So now we'll go to set the Z. So the first offset's set there, and I'll go over and do the same on the second offset. So I'm going to call this one G54.1 P10. So there's a whole series of offsets based on G54.1, P10, P11, P12, and so on. So I've jogged over to this corner now, and we're calling this G54.1 P13. Just a note for the P10 onwards work offset numbers. So you put G54.1 and then P10, 11, 12, whatever number it is. When you press enter, it sets that work offset. But unfortunately it doesn't show down here in the status, and so one way I can see where it is if you go to the work offsets page, you can see a yellow line through P13 and you can see that's not yet been set because it's still on 0. There's probably another way of finding it in PathPilot, I just don't know where it is. I've just done a test run of 2 parts. I don't want to have 8 rejects, so I put in a couple of reject parts just to test it. You can see the parts are held in with this clamp in the middle and located in a rotary position there with a pin or a drill while I'm tightening it up. So anyway, here we are. We've got the engraving on one and we've got the sequential serial number there, number 400. Then it moved over to the next work offset, did the engraving again, also machining the cap screw counterbores, then went over and dialed up the next sequential serial number, number 401. So it all seems good. Is it possible that there's a mistake further on in the code, that I've set something wrong? It could really only be that I'd set an offset wrong. Now I've proved it 99%. So I'm fairly safe now to put the whole 8 parts in and run it. So now it's going to run 8 times longer, and it's a serious amount of time to go and have some lunch or do something different. Okay, we're just going through this one more time very briefly. So you've got your starter block, then you're putting in the letter O and the number of your sub program, O1 sub, because I'm using 1, the content of your toolpath part of the program here, then O1 end sub, then you're putting in the offsets, O1 call, G whatever, O1 call, G whatever, O1 call, ends on an O1 call. Then you've got the end block, you know, just the shutdown block there. So these are my positions, G5 4.1, P10, 11, 12 through to 16. So looking here on the actual code I've produced, just going through that again. At the top you've got your starter block. Here after spindle on, I'm putting in O1 sub. Then you've got your toolpath Gcode all the way through here. It's quite a long program. And then right at the end, down, where are we? That's the serial number engraving there. Right at the end, I've got O1 in subroutine toolpath. Then I got my O1 call, G54.1, O1 call, G54.1, P10, P11, sorry, P12, P13 through there, and then right at the end it finishes on an O1 call. And then finally you've got your end block, coolant off, spindle off, M09, M30 and so on. So that's the whole lot there. It should run, touch wood. And if we close that down, I think I saved it, go to the main, you can see there the 6 different positions. That looks about right. And if you go to the offsets page, you can have a look at, set it on G54 and have a look at the relative positions to make sure you haven't put a typo in there. You know, with 8 offsets you could easily have a typo and a disaster. So that all seems good. Here we are, all done. Looks like it went well. So you can see the sequential serial numbers 405, 6, 7, 8 through to 412. And the fixtures work well, nothing looks like it's turned round, it's gripping well enough. That was really satisfying. So I quickly made a little mild steel plate and some clamp washers, set it up and learned how to use subroutines to cut the different parts, to cut the different work offsets, and then use the sequential serial number system. And I found that quite challenging. For my practical non-academic brain, it was a bit of a struggle, but it's come out well. So I won't go into how to use PathPilot to engrave sequential serial numbers, because it's fairly well explained in the operator's manual. And also I did a video on that subject alone about 4 or 5 years ago. If you go back through my Thread Express YouTube channel, you'll find a video on sequential serial numbers. So basically you use this conversational to produce the macro which is inside the software, and that clicks over another number each time the toolpath is run. And so you set the number you want to start with here, and then it carries on from there. And at any time you can re-enter whatever number you like there. So thanks for watching. Please put any comments below, and I'll see you next time. Cheers.